Hi and welcome back everyone to our channel, and in today's video we'll be talking about the derivative still of trigonometric function. And today I will show you why the derivative of cosine of x is equal to negative sine of x. And again, as a prerequisite knowledge, please remember that this limit from your pre-calculus subject is still applicable in our proof, plus the sum and difference formulas from your trigonometry in your previous subject. We'll be using them in the proof of our derivation for the derivative of cosine of x. So the theorem states that if a given function f of x is equal to cosine of x, then its derivative is equal to negative sine of x. So the proof of this theorem will be using the difference quotient formula, which is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so our f of x is cosine of x, so our next step here will be the limit as h approaches 0 of cosine of x plus h minus cosine of x. This is minus cosine of x because our f of x is cosine of x all over h. Okay, and then our next step will be we will expand cosine of x plus h using our sum and difference formula, this one. Okay, so cosine, so that is minus, so this will become negative the limit as h approaches 0 of cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. And then we still have here in the last part, I will change the color so that you can identify that our last term here, we still have cosine of x, and this cosine of x came from this original value of f of x, and this part here is just the expansion of cosine of x plus h. Okay, so do not be confused. This whole expression will be divided by our common denominator, which is h. Okay, so same as the process in our previous proof, our limit now as h approaches 0 will be equal to this one, cosine of x times cosine of h minus cosine of x. I have rewritten the numerator and I have combined terms, and those terms are terms with cosine of x because my plan is to factor out cosine of x. Okay, so I have here this term cosine of x and the quantity of cosine of h minus cosine of this cosine of x. This one here came from this one. Okay, and I will retain the remaining terms, sine x and sine of h. Okay, all of them over h. So we are not yet ready to drop the limit sign, so still we have the limit as h goes to 0 of this one. So I could factor out now cosine outside, and I will be retained with cosine of h minus 1. Okay, and then I will separate them over h minus sine of x times sine of h over h. Okay, I have separated now the whole expression previously in this step to two terms because you know that we could separate them because h is the common denominator. So by rewriting again the previous step, the limit now as h goes to 0 of this function, I could rewrite this one as cosine of x times cosine of h minus 1 over h same thing, because this is over 1 and 1 times h is still h. Okay, and on the other side I could rewrite this one also as sine of h times sine of x over sine of h over h. Okay, I have rewritten this in this manner because I know that this expression here and this one, I could use our previously known knowledge in your pre-calculus subject, which is this one and this one, which is respectively equal to 1 and 0. Okay, so take note why I have rewritten our numerator and our expression in that way. So this time we are very ready to drop the limit sign. So the limit of cosine x is still cosine of x. So this is cosine of x. And the limit of cosine of h minus 1 over h, this is equal to 0. As you could still remember in our previously known limit, this one. Okay, so that is equal to 0. Okay, minus sine of x times this whole expression here will be equal to 1. So I will be left with 0 minus sine of x, and finally our f prime of x is equal to negative sine x. So this is now the derivative of our given function cosine of x. So as of this time, if somebody would ask you why the derivative of cosine of x is negative sine x, well, this is the answer to that question, and I think the process is a little bit longer and it looks like a very complicated one, especially if you could not still remember the concepts in your pre-calculus subject and in your trigonometry. So my advice, do not forget all of the things that you have learned in the past, because in the future you'll be using them. Thank you very much and see you soon in the next video.